Let's start. So today we'll see the concept about threads and how the threads are really helpful in the real world applications, and how we can create our own threads or the JVM related threads, and what is the difference between them. So we'll see all those context things. So it will be more of a starting would be a theory, and then we'll start looking into the practical part. And so before going to that, you have any questions so far in the topics covered on collections or the IO handling part or the basic Java related concepts? Because only if you're strong enough on the interface, abstract class, and inheritance, it would be more easy to understand the thread related things to implement and work on.
Yeah, so I'm okay with the concepts. I still need some more practice.
Okay, but you can understand the concepts, right?
Yeah, I can understand.
Yeah, okay. So let me share my screen. So any idea what is a thread and what is a process? Have you ever come across these two terms?
I have come across these terms, but I don't remember exactly.
Okay, so you knew the taskbar, right? So what is the taskbar does?
Taskbar, you mean in a web
In our
browser?
usual system, we have the taskbar, right? Like where you have all the applications running in the backend.
Okay, so taskbar.
So usually, like if I just open the taskbar here, so you'd be able to see the number of applications which are running in the backend.
Okay.
Right? So this is nothing but the processes. You can see the term processes where you have like each application is running as a separate thing. So the what is a process and how is that related to thread and what is the difference? So we'll see on that context, and then we'll come into the Java related thread concept. So the process is nothing but basically a program. It can be any program, it can be an application, or it can be any kind of programs. So which are actually like in a ready state. So they are like executing, they are happening, they are in work, and they're not like idle. So in that case, what happens, your backend CPU will create a space for these programs to be in ready state and get executed every time. So we have something called process control block. So in CPU, we have something called process control block, which is PCB. That is one sector in CPU, which actually holds this particular concept of process. So what happens is this particular PCB creates the process for each of your program. And this will also create sub-child programs in it. So if you have number of applications within your Chrome, all these would be your sub-process and this would be your main process. So it is like more of a parent and child process running. So we sometimes see in Linux, we have to do the forking part when we have to create a process. So in OS related things also you have heard the term fork. So all these are nothing but the process. It takes time. Okay, it takes more time to terminate. So if you want to end your application, you have, though you close your app manually, you can still see that process is still running in the backend. So we manually go and clear it out and dispatch or terminate that particular application. So if your particular process is not terminated, in that case, how is this particularly being executed? So all these processes do not share any memory in common. So they are like, this is particular separate process, this is separate process, this is separate process. So all are independent. They do not share any memory in common. So they have these states like, I'm like pretty new, I'm at to start. There is ready state, which is actually like, I'm ready to start. You can click on me anytime. And there's something called running, which is like the process is still in working mode. And you have something called waiting, where you might have terminated. Sometimes if you open any kind of application, the browser or any kind of editors, it will be like loading for a longer time. In that case, it's stuck. So it is not getting the connectivity from your CPU, or it might be overloaded with high capacity. So in that case, your process would be in the waiting state. And the other one would be the terminated, where you completely close and crash your program. And suspended is again similar to that state. So these are the states where you can say like whether your process is pretty new, or it is running, or it is waiting, or it is closed, whatever state. So this is called as a process. So basically the process is a individual program and they do not share memory. So these are the 2 points we need to take in before going to the threads part. So this is generally what you see from your GUI perspective. So coming back to this thread, okay. So what is thread? Is the thread is again a part of your process. So we can say a part or a segment of that particular process. So this is like a sub-child within it. So in that case, what you can say is a process can have multiple threads. So this is like one process can have n number of threads. So this is the relation we have between a process and a thread. So this process is like when we come across a term called multi-threading in Java, we'll be often seeing this term in this week, which is called as multi-threading. So what is multi-threading? Is like parallelly, like you will be executing multiple threads from a single process or from multiple processes. So parallel execution of threads. It can be from single process or it can be from a different process. Okay. So all these multiple threads are executed within this particular process. Okay. And in this particular threads, like sub-child of this process, we have thread. And this has a state again, like running state, new state, or ready state. And you can also have locked state. And you can also have terminated state. So we'll see everything one by one with real-time examples. But this is the thread. So why do we need a thread within this process? What is the need of it? So when you have your Google Chrome open and you have like 100 tabs opened in it, all the 100 tabs will not work from single process. You need to assign a resource like, okay, this particular tab is taken care by, say, thread 1. And there's a 100th tab which is being taken care by thread 100. So these two threads have to be in communication. So where your parent process had the major control. So this particular thread takes less time to terminate compared to your process. So these are sub-processes of your thread. So sub-processes of your process. So what happens? You have less time to terminate. So you don't take much time to terminate any kind of program that is running with the help of your threads. Okay. And these processes are isolated. So when you check your thread task manager, right? So every program is independent. You didn't have a connection between these two. So these are all isolated, like they're not like connected together. That is what the process does. Whereas in threads, they would be in together. So they do not isolate. They do not isolate, whereas the processes are in isolated mode. Okay. So what happens within one particular Chrome, you have sub processes. And in that sub processes, you will have like multiple threads running, and all those threads will not be separate. They'll be a group activity. So they do not isolate. So here they do not share memory, whereas in your thread, they share memory. So how does actually the structure look like of the process and thread is? So here you will have this is let's say this complete one is a thread, okay, and this thread would be like something like this. I'm just giving a sample, and what happens here is this would be your the code part or the data part or your stack, or it can be a heap, or it can be any CPU registers, anything. It can be into anything, okay. So this can be in anything, and this all will fall into the process. So this entire thing is a process. And this within this process, you have a thread internally. So this would be the structure. So I can just erase this. So this would be the structure. So a process will have thread, and that thread, and internally for each process, you have its own stack, data, and its own registers to work on. So the basic difference between the process and the program is the process is like what to say, the individual programs, whereas these are not an individual programs and they do not share memory. Okay, so have you ever heard about the term context switching? So this is something like basically in operating system, when you learn about operating system, you'll heard this word of context switching. Have you ever come across that?
So I've heard this in Oracle.
Mm-hmm.
So Oracle switches between PL SQL engine and Oracle SQL engine whenever we run a PL/SQL block. So
Okay.
bulk data handling.
Okay, so I'll explain that a little late. So
Yeah.
before that, the process is like it will have a shared memory. So a thread will have a shared memory where your processes would be having a separate memory. So they do not share memory in process, whereas in threads they have a shared memory. So if you have multi-threaded multi-threads, all will have a common memory. So simple example, you have a bank account and you're gonna do some debit part, okay, and parallelly someone is crediting you. Two things happening together, and in that case it is a single account and it's not your two accounts. It's a single account where you're doing a debit as well as a credit is happening parallelly by someone else. So what happens, both the activities should be updated in the same account and not in a separate account. So if you upload your thread related details like debited and the final amount in one memory and the credited amount in separate memory, there will be a mismatch in your amounts. So to avoid those mismatch, what we do is internally we'll have a similar threads executed or multiple threads with the same memory. So what happens, the data would remain same in constant. There will not be any kind of conflict later. So that is the reason we always prefer multi-threading or multi-programming or parallel programming when you have such kind of scenarios. You might not predict like this will be only one time activity or one person's activity. You'll have like multiple interactions in the same thing. Say for example, if you have a database, say you have an employee login table. If he's logging for the first time, he will get an OTP, and that OTP, the first time OTP has to be updated in the database. So it's a one-time activity. But every time he logins to the application, you need to log in the number of attempts he took it to log in or the number of time he took it. Something you're tracking the login activity. In that case, what happens? You have to update in the same entry of that particular user. Say Kiruba, he's the username, and here he's been logging on this particular time through this particular browser or IP address, and that has to be updated in the data time. So again, if he logs in after a week or so, that data has to be updated. Maybe it can be 1 to n or it can be 1 to 1. You are updating the same column name, or you might be maintaining a different table for all his entries if it's a confidential application. So in that case, what happens? Your user ID is common, but the number of attempts is trying to log in or through a different IPs is getting varied every time, which has to be updated parallelly in your database. If you just think like this particular user Kiruba has logged in and I just give an entry in database, he's logged. Yeah, the flag is true, he's logged in. But I never knew that what IP address did he log in, from which country or from which place. I can't track it out, those details. If I update little later, and what happens in that case, my DB update might be failure, or sometimes the DB might be not getting a connectivity, and this would be a delay in updation of transactions. If this is a sample for login, what if you're doing some kind of activity on your transactions or payments? If there's any delay, like say you have debited 10,000 rupees from your account, your balance is null, but still in your account you see like 10,000 available, and you try to use it again for one more debit of 10K. Will that be a proper scenario?
No, Sneha.
Yeah. So for that purpose, what we do is we always prefer to have multi-threads. So we'll see like what is the producer consumer problem, how, where and all in real time we can go for the threading part. So whenever you wanted to make a parallel call. So in say example, the real time WhatsApp, you wanted to make a call to 5 persons at a time. So what happening in a single call, you're trying to connect 5 people in the back end, but everything is happening in a single process through WhatsApp. So this kind of connectivity where your thread comes into picture. And internally, like in WhatsApp also, through the Erlang language, they have coded something on the thread related things. So similar way, if you go for any kind of application, even in Python, or if you go for operating system programs like system softwares, anything, internally, this thread concept is something happening in backend, which we might not be aware of, but the architecture still maintains the thread and process concept. Without this, we'll not be able to do a multiple activity as an end user. Yeah. So that is the thing. The threads will have a shared memory. So all your things like all the thread related information like the code, data, whatever you have seen here, right? All the information similar to your process, everything would be lightweight because a process is a heavy loaded one, whereas thread is just a minor part in the process. So it is a lightweight process. So the thread is something called as a lightweight process. So you might not load with heavy data, but it is very difficult to track which thread is working and when, and what happens if one thread is down. That the level of tracking and maintenance of the orchestration would be different, would be difficult, but the maintenance would be very easy because it's a very minute thing than compared to your process. So that is the reason we never create a process. We create threads in our program and use them, because in the backend we have only one process. Yeah. Yeah, this would be the major differences we need to know from a Java perspective. Apart from that, if you're interested to know more about this, I can share you the link to understand the processing threads in a more deeper concept about the process and thread in the. So now let's come and see what is actually happening. I see this context switching in some time once we learn about the creation of this threads in Java. So in Java, these threads are coming again from your lang package. Java.lang package. Let me quickly open this. So far, any questions or any queries you have on this one, on threads or process?
No, Sneha.
Okay. Okay. So we knew that there is a driver class in every Java program. We were creating a main method, and it was actually helping us to execute a Java program. But what is this main? Main is internally again a thread which has been created by your JVM, where all your processes which you're trying to execute, or the code which you're trying to run, everything is happening in the backend through a thread, which is nothing called as daemon thread. So daemon thread is something like which is being created by its own instance or own JVM architecture, where it is being reused. So it is like kind of like, okay, this is my activity. Someone has to trigger that. Only if you trigger, I'll be able to start. So for example, if you have a bike, if you have just bike, you'll not be able to start and travel. You need to kickstart it, or you have to do an automatic start, and then only on that purpose the bike starts running. Before that is just static, it's idle, but you have you have your thread ready, you have your bike ready, but it's not actually ready to travel. So for that purpose we need to kickstart. So the same way in JVM we have an internally a daemon thread, which is nothing but your main method. And to do that, to create your activity or to run your program in the backend, we need to write your own piece of code to start it. But this is something like manual. Once you use this, it will start by its own. So it's like automatic. But for few of the processes which you create by yourself in your programs, that has to be explicitly mentioned that I have to start this thread, otherwise it will not work. So how do I start and how do I create my own thread in Java? So in context of Java, whenever we are executing program, like if the thread demo is my class, you should have at least one thread in your class. So right now, main is your one thread, which helps you to trigger your entire thread and work on this particular program. But you should have at least one thread if it's a Java program. And by default, it will always be main method. But if you want to have more than one, you can create your own thread in it. So how we can accomplish by creating a thread? So there are two ways to create a thread in Java. So one is by extending, which is your interface concept. So one is by extending the thread class. The second way is by implementing the runnable interface. So what are these two? Let's explore that. So first, let's see how to create a thread by extending your thread class. So the thread class comes from your thread java.lang package. So let me create a thread. E1 equal to new thread. So if you see this, this is internally is again implementing something called runnable interface. And this interface has something called run method, which is an abstract. So wherever you use your thread class, you should have your own logic for run. So here you see if the target is not equal to null, you are just executing this target.run. So this target is nothing but your thread. You're just telling that you try to execute this particular run method. So in your case, let me say I'm just printing system.out.println p1 dot. I'm just getting the ID. So let me just run this. So if you see right now, I got some random ID of 12. The name of the thread is thread-0, which is being created by your JVM. And the priority has been given as 5. And the state is right now new because you just created the instance, but you haven't mentioned like to start the thread or to execute or run. You haven't given any kind of information or a task to do this. You just created a thread. So it is like a pretty new object. That's it. So the state is actually new. And what is this priority? So how does this priority matters to us when we come into the thread handling? We'll see that again. But right now you see a priority is being defined with some value called 5. Let's just note that. And the state is in with new. And you got a thread name named as thread-0. Okay. Now, let me give T1 dot start. Okay. And now let me check my state again. If you see right now, the state is this runnable state. So what happened? What is the start method does? So you can observe a synchronize keyword. So let us come to synchronize once you start doing multi-threading. But let's see what is happening. If your thread status is not equal to 0, and what you're doing is you're just making that particular thread to start with some task, and it can be any task. Whatever activity you give as part of your start, it will do that. But how do I know that is actually getting started or not? So let's say, let's have one more class. So new Java class extend. So what I'm going to do here is I'm just going to give extends thread. And here, let me have my own method called run. I'm just giving system.out.println. Now I'll have my own main method, the one which I have usually. And what I'm going to do is I'm going to create an object for my own class in this. And let me give the thr.start. So I'm starting the thread of my own class because this is extending this object. So I'm creating my own start method. Okay. And let's see what is actually happening. You see, a run method has happened. So I didn't call this run anywhere. I didn't use this run anywhere. But when I gave this start, it actually went to this run method and it started executing this running statement. So what is happening? Who makes this actually who makes internally a call to run. What is actually happening is like, whenever you create this particular thread constructor, right, the thread extends something like this. Whenever you create an instance, when you extend your thread and you're creating an instance for your class, the thread constructor will allocate a thread object, which will be in new state. So what happens internally, this is getting extended from your thread class. And here you can see a thread with thread overloaded constructors. So if you go with this, the thread is actually initting. It's like initializing the thread object with all the information, something called thread group, something called as runnable, some name, and some stack size. Is actually initiating an entire thread. Okay. What I'm not doing it explicitly, but internally, since you're extending your thread class, this actually does it. So right now I didn't give anything. So I was using just a default one. And if I go into this, there's something called thread number. And if you see the thread related name, it is always going with thread hyphen. So earlier when you checked what was the thread name, it was thread hyphen 0. So that is the reason you got here, because it is hard coded as thread hyphen. So every time you get a thread with thread hyphen, and you have something called number. This number is nothing but the stack size, like in what stack size you want your thread in within your process. So you have to give that. And what is this thread group? We'll see that also in some time. But who does this initialization is someone, whenever you extend your thread, this particular class itself implicitly takes care of your thread creation. And you're just going to tell to start. This is like a kickstart. Like I'm going to kickstart and travel. That's it. And what happens when you put your key and switch to your write mode, then immediately you can go and travel, right? You don't need to tell engine or explicitly someone. So similarly, whenever you give the start method, internally this run method, whenever you see this thread one, it is actually using an interface called runnable, where you have a run method. And this run method is being overridden in the thread class by giving its own logic, where you see the target is not equal to that, you have to just run. So I'm just again overriding the same run method over here. And internally this has got started. Say let's example, I'm using a different method name. Run one and run it. Now you see there is no running one happened. So this run method is something which is getting overridden from your parent class thread. And because of that, whatever you have given as an instruction within that method is getting executed. So this is one way to create your own thread. Okay. How can we create our, by using an interface, thread interface? That also let's explore. Thread runnable. So since it is actually implementing, instead of not extending the thread class, what we are going to do is runnable. Let's go there. Implements runnable interface. And whenever you give your implements, you have to override your run method. Okay. So let me give the same sys out. And now let me create my own main method, which we need to trigger. Let me create the thread runnable instance. And let me see whether I'm able to see the start method. So see here, this time when I implemented the runnable, I'm not able to see the start method here. So how the start comes from? The start is available only in your thread class, right? You have only here. Only here you have your start method, but you don't have it in your runnable. Runnable has only run method. So how should I start my thread if I don't have my thread instance? So for that purpose, you have to again create a thread object, usual thread object from your thread class. And to that thread, you have to pass this object, whichever class is using your runnable, you have to pass this particular instance. So since this thread is an overloaded constructor where it can accept a runnable instance also, which is a target instance. So what I'm doing is I'm passing my run, which is a runnable interface instance. And with that T1 instance, I'm going to trigger my start activity. So what happened here? This time we are not extending the thread class. Instead, we are implementing the interface, having our own run method, which has been overridden. And the creation was little different because earlier we just created the object for our own class because it is internally extending. But this time we are creating an instance for your class where you're actually creating your own interface based on the runnable, and you're creating your own thread and passing that runnable instance, and then you're triggering the start method. So let's execute this again. So you can see again, your thread is actually working. So what is the difference between extending a thread and runnable? Because extending thread is more easy because if you extend thread once, you can just go ahead and create your instance and kickstart. But if you're using a runnable interface, you might not you may not have the eligibility to create your thread. You need to do it explicitly. But what is the difference? So can someone say difference between extending and implementing and why this interface came into picture? You remember?
In implements, we will just have abstract methods and those things, right? Like there won't be any left.
Okay.
Like only declaration will be there.
No. Like why did this multiple, why did this interface concept come into picture in inheritance? Because we had the same thing in threads as well, right? Like you can just extend thread and get it. But why this interface concept came? My question.
For that multi-level or so, like two parent, single child for that concept.
Yeah, exactly. So whenever you wanted to have more than one thread, like if you have like a class with, say this is a parent class, and you wanted to extend one more class in that concept, you might not have this eligibility to do the same thing in when you do extends thread, but it can happen in case of your runnable interface. So that is the reason Java has given the feasibility to create your own thread class by extending or versus by implementing your runnable interfaces. So when you extend this thread class, you can't extend any other class in your case. Say example, if you're having a abstract class relation, okay. For example, a parent was digital laptop, and let's say parent has laptop and your child has digital laptop, and or you can say it's a tab or it can be a phone. So you have your three childs, but your top class name is like just a mobile device. So in this, what happens if you wanted to extend something to your child class, you can't do it if you do this extends thread. So in that case, we might fail in the concept of multiple inheritance. For that purpose, what has Java has given is if you don't have any kind of inheritance relationship with your actual class where you're trying to create your own thread, then you can go with extending thread. But if you have some kind of relationships like abstract class maintenance or some kind of child-parent relationship, then it's always better to go with implements runnable, where you can create your own thread and kickstart your thread. And you don't have dependency on extending that particular class. So here, you can just give extends keyword and you can use the respective class name, and then you can go on with the actual logic which you wanted. So that is the reason Java has given these two frameworks to create the thread. So that the main reason is we miss the inheritance benefits if you do in this case. That is the first point. So that is the reason which one do I need to prefer? Should I need to prefer extends thread or runnable? Most of the multi-threaded programs will always choose this runnable because we might have some kind of inheritance relations in our program or in your code based on your use cases. In that case, we might fail to go with this particular one. So that is the reason we always prefer implementing runnable interface. And in this, we actually create explicitly our own thread object and kickstart our thread instances. So like, are you clear so far? Like, why are we going with runnable and not with thread extends usually? But this can also be done if you don't have a multi-threaded environment or if you don't have any parent-child relation. Any questions so far?
No, sir.
Okay. So as I said earlier, we'll see what is this main thread is happening. We'll see what is actually prints. Okay. Let's create a parent class. Okay, let me have a method, say parent. This is now let me go to this runnable and I'll say here extends parent thread. So this is running, and let me create an object here, and I use run dot parent. I'm just executing that, and I'm creating my own thread object, and I'll start it. Let's run it. So you can see a running parent happened, like printed twice, and this run method. Let me just have one more thing here. Running main, running thread, execute it. So this is main thread, okay? So from your main thread that is getting printed, and your thread instance is getting printed, which is running thread. And before that, you're executing run parent, that is also happening. So if you see the order, the run parent, okay, which is your run parent, this is the one. So this is happening the first, that is the order of execution. But if you see the next one, I created the thread t equal to new thread of run, and I'm starting it before line number 15. But this is happening in which case? In main method. So before the t1.start is getting triggered and printing running thread, I see the main is getting triggered and the running main is getting printed first. So internally, the main is also a thread. So this is your thread object 1, and this is the thread object 2. So even your main thread acts as an individual thread, and internally, whenever you create your own thread instance, that can work only from your main method. So that will be your secondary thread. So any doubts here?
Can you repeat again? Like parent, I understood. Like first thing will be parent will be executed.
So where are you executing this run.parent? From your main method, right? So I created an instance from my thread runnable class, and I called run.parent because this is extending parent thread, and this is printing running parent on the first class. Okay, this is on the same order of execution. First two lines got executed. Now again, the third line thread, where I'm creating a thread instance for my class, and I'm calling t1.start. So whenever I call start, what happens? The overridden method run has to get printed. So the running thread has to come second, right?
Yes.
But what happened? We got running main. Why so? Because internally the JVM thinks the main method as your thread. So this is like a normal inheritance relation. So there's nothing with thread relation. But when you create your own thread instance and you call it, even you call your instance before your main method, the running main is getting printed first because this is your first thread in the backend. And later then your thread is getting created for your own class thread runnable. And with that, the running thread has been executed. So the order has been changed, right? So it was not like thread running thread on first and running main in the second. In the vice versa format, it happened.
Okay.
So the thread execution will not be static every time. It changes every time. So that is something we need to understand. So now we'll see what happens if I give this start twice. Okay. I just give T1 dot start here. Let me give again T1 dot start and run. You see something called illegal thread state exception. So what is this illegal thread state exception is whenever you kickstart your bike, you can make it on only once. You can't make it multiple times, right? So the on can happen only once. You can say, okay, otherwise it is off. Only once you can make it to on. So when you try to do on twice for the same thread, it will say like this, I can't handle this because I can handle only one kind of triggering point and not multiple triggering points to the same object or the same class. So I need to handle that. So you can't execute more than one start. Okay. More than one start you can never do, which ends up with an illegal state exception. So by mistake, in any chance, when you create your instance to start multiple times, it will end up with thread state exception. So you cannot start a thread multiple times. It's only one time activity. So you need to just call the start method only once. So are we clear till here?
Oh, yes, ma'am.
Okay. So let's join the second invite.